class with you all. Okay. Actually, this topic I need about 4 hours to cover. Okay, but I will cover 1 hour in here today, and another 3 hours I will provide a recorded lecture so the teacher has been can teach you starting from next week lah. So I recap again what you learned so far. Firstly, you learn about the force, and then you learn about the resultant force, and then after that you learn about equilibrium, and then after that you learn about moment. The moment divided by 3 is a number 1 number, and then about n at least, and finally couple moment. So everything that we already covered is around 6 weeks. Okay. So the final topic with me is we have force, we have resultant force, we have equilibrium. Actually, we have moment, and also we covered the resultant moment. Already covered. So what do you think here? What is the topic here? We have force, resultant force, equilibrium. We have moment, resultant moment, and also what is it? Agak-agak. You see the pattern? Moment, resultant moment. Yes, equilibrium. Same thing. Actually repeat. However, the target here, firstly everything about force. Okay. So the second half everything about moment. Something like that. So it means that because I want you to see the whole pattern that what we covered lah. Actually in our life in physics, actually we have force. Force is something that force left, right, up and down. Moment is about what is it? Is a rotation. Moment is a rotation. Something like that. So it means that a moment is similar with the force. However, the movement in rotation. Force is something left, right, up, and down. Something like that. Okay? In a straight line. Force, straight line. With a rotation. So that's why you learn everything, like, because everything this is a movement in our real life. And then after moment in physics, if we have a system in the body, we also later on you will cover by Dr. Shazmin is inertia. Inertia. So it means that everything same, however we look one by one. Okay? So that's why we learn about the equilibrium of moment. Okay, so for the equilibrium, for the force, the summation of force equal to 0. Yeah, summation of force equal to 0. Saya terkejut apa boleh santai. Pokoknya ada lah biar itu. Okay, for this one, for the force equal, the summation of force equal to 0. Since we talk about vector, so it means that the force is divided into 3 lah, which is summation of fx equal to 0, summation of fy equal to 0, and summation of fz equal to 0. Okay, alright. So, for the equilibrium, for the force, the equilibrium of the force, summation of force equal to 0. if equilibrium for the moment, so you can get what? Summation of moment equal to 0. Something like that. Yeah. So the moment in vector or scalar? Moment in vector form or scalar form? Vector kan? Okay. So if the moment in vector, so we can divide it that the summation of the m about x axis equal to the summation of moment about y axis equal to and summation of moment about z axis equal to 0. Something like that. Okay. This is our target lah. In order to settle for the moment the equilibrium of the moment, we need to refer to this thing, okay, information, and also we need also combine this information together. Okay, so we need to use this information and this information in order to solve for the equilibrium of the moment. Okay, so that's why you learn stage by stage. You need to have the first knowledge in order to settle for the second knowledge, something like that. Okay. So the initial later on will cover by PM, Dr. Shazmin. Right now in the e-learning, if you read, we now at the slide 5. In the e-learning right now, for this topic, we look at slide 5.1, 5.2, and 5.3. For this topic. Okay. So, for this moment, at the first part here, we consider 2D and 3D. Is it? For the moment here also we need to refer 2D and 3D. So that's why I tell you that I need 4 hours in order to cover for the whole topic. Okay. So, we focus. I give you a question. I give you why you need to remember. I give you one example. This is the normal question. I just give you this thing. And then the question is apply scalar equations of equilibrium to solve for the unknown. Okay. So now what is the unknown? And then you don't know what. Because you just only have A, B. You just have this thing, and 4 kilonewton. So what is the unknown? Okay. So that's why you need to remember this concept for you to know what is the unknown from this. So you need to label based on this figure only. You can label what is the unknown. Okay, so that's why I said that for this thing you need to have 2D and 3D. Okay, so for 2D and 3D, I will divide into two places here. This thing we call as if you look at this thing, it's called as hinge. The name of, you know that when you want to put something in the wall, can it can move up and down, something like that, kan? So this name we know as the hinge. Okay. So this is 2D or 3D? 2D, yeah. So let's say if we use hinge, something like that, this is hinge, yeah? Automatically you will automatically know that should be there are two forces applied at here, which is AY and if the material used is a hinge. Let's say if the thing here you put this beam straight away to the wall, something like this, you fix it to the wall, okay? We know we name it as a fixed support. This is hinge. If you use fixed support, automatically you will have same thing, which is AX, AY. However, there is another additional thing. It also will create a moment of X. So it means that if you use this one, is there any moment here? No. You only have AX and AY. If you use this one, you fix it at the wall, you should have three things: AY, AX, and moment A at the X axis, because this is X axis, right? So you will have moment of X. Is it clear? And then if you have, we will focus only three. There actually a lot, but in this course we only consider three for the moment. Let's say if you have roller ni nak, yalah, two lah, okay. You just need to remember two for the 2D. No need. Okay. However, for the 3D, we have this one. Let's say this is this, and then it just have a very minimum connection. We name it as a smooth surface support. The name is. So the only one thing apply, which is one force only. There is no moment. There is no nothing. Only force. Okay. And then after that, if you have this kind of thing, bearing, okay, this is bearing. If you have this kind of bearing, so they have, let's say this is y direction, this is x direction, and this is z direction. So they are, you have fz, fx, mx, mz. Okay. The easiest way for you to remember, if you look at the road at the y direction, you will have the force and moment without y direction. If the road at the x direction, so it means that you will have force and moment without x direction. That's how you to remember. Something like that. Because normally, most of the time, in the exam and so on, for 2D, we'll use these two. And then for the 3D, almost like this, we use this one. Okay? I think for the 3D, cuba lagi satu, one more. And the last one is and finally we will have this one. This one we call Excel. Betul. Pintu. For the door, single hinge. Okay. For this single hinge, you look at, let's say this is Y, this is Z, and this is X. Okay. Actually, single hinge is similar with this one. You look at the road, go to the Y direction, so it means that you will have MZ, you have FZ, you have MX, MX. However, the additional you have FY. Same thing. Is it clear? Okay. So now we have this information, and then we have the question. So we want to apply to solve this thing. So in order to solve this thing, firstly, this is compulsory step to solve. The first thing you must draw the free body diagram. You must draw the free body diagram. So it means that okay, this is 2D. We look at the 2D area. This one refer to hinge or fixed support. Hinge, is it? If the hinge you only have, do you have moment? You don't have moment, is it? So you have a x and a y. So just put it, you have a x and then you have a y. Here also you have a x and a y. But this one, this is only support. Support, yeah. The main body here is this thing. So we just put the AX and AY at the main body, not at the support. So it means that if we need to remove this one, yes, we need to remove this one because this is support the main body. Okay, we just put the at the main body, which is AX and AY. Okay, so we need to consider everything at the main body. This one, yeah. Is it just a very simple connection? So, if I can put it something like this, you have AX and AY, and this part, because it is very small, so you will have another force. Then force to support the thing, which is F. And then after that, you have another force here, which is 4 kilo. So this is the free body diagram for this. So in conclusion, that in order to write anything to find the unknowns, or you need to find the thing, firstly you need to find the connection of the main body to the ball, the first thing. And then, or I can repeat again, you need to identify what is the main body. This is the main body. You need to identify whatever support or connection between the main body and outside the main body. So in this case, this is the main body. How many outside connection? 1, 2, 3. So you have main body. For the first connection from the main body to the outside is here. Since this is used hinge, so you need to look at the hinge. You have AX and AY. So you put AX and AY. And then for the second connection of the main body to the outside of the main body at this point, is it? So you look at this point. Oh, this is only support. So the support you just put as force support. And then the third connection of the main body to the outside of the main body, this is the third connection. So you just put 4 kilo distance down, something like that. Sketch the free body diagram. Okay. Sketch the free body diagram. This one actually refers to which one? Single general bearing, kan? The root at the Y, X or Z direction. The root Y direction. So it means that since the root at the Y direction, so at the point A, the free body diagram, you will have what? X, this one. Because of the root at the Y direction, so you will only have X and Z only, is it? So you will have Fz, Fx, and then moment X, moment X and moment Z lah. You look, the root at Y direction, but you only have at the Z and X. Do you have any parameter Z and Y? So same thing lah. The root at the Y direction, so you only have X and Z only. Do you know the direction of the moment of Z? Remember, yeah? Fz is going up, so your hand is counterclockwise of this. So it means that this is the moment. This one, Fz, Fx at here. So you will have M X. Okay? And then after that, how many connections you have? 1, 2, 3, and supposed to be at your free body diagram, you will have 4 points that you need to consider. And after that, it travel at this part and then go there again. Okay. The second one, going down here. We name as the FB. At this point, B. So name as the FB. Yes, for now. And then we go to the third location and the C. Another force going down, is it? We name as the F. C equal to 80 kilonewton. And then finally, at the D. Is it force going up or going down? Going up, is it? The force is going up. It is D. We name as the F. So this is the free body diagram of this system. If you know, so in conclusion, I can say that for the resultant force for this system, I will name as a, because this is A point, I will say this is F at FA at the X at this. This is FA at the Z at this. This is FA at the X at this. This is FA at the Z at this. Okay, so in conclusion, for the resultant force here, how many force do you have for the FX? Do you have any X force? No. So Fx actually equal to FA X. Because this is equilibrium, so it means that the summation of force at X equal to 0. So this is also equal to 0. Okay, the summation of the Y, Fy. Is there any force at the Y direction? No, again. So, equal to 0. So, it's nothing. Okay. And then the summation of the Fz, I put it here. Summation of Fz. How many force at the end, at the Z direction? You have 1, 2, 3, 4, which is Faz. Going down will be minus Fb. Going down again, minus 80 kilonewton plus Fd equal to 0. Okay? Summation of Fx equal to Fax equal to 0. Summation of Fy, nothing. Nothing, eh? Summation of Fz equal to Faz minus Fb minus 80 kilonewton plus Fd equal to 0. So now we want to find the summation of Mx, summation of My, summation of Mz. Okay. I give you the length here. This is 3 meter. This is 3 meter. This is 1.5. Okay. So now, the Mx, you will have the first moment, is it? Which is Max, the moment at the X. If you still remember on the previous topic, when we apply the force, automatically you will have moment at the force. If you apply the force, you will get moment for that force. If you apply the force, you will get the protection, is it? Okay? Same thing in here. So you need to find the moment at the B axis. You need to find the moment at the C axis. You need to find the moment at the D axis. So it means that the summation of the moment you will need to find plus moment at the B at the X axis, moment at the C for the X axis plus moment at the point D for the X axis. Okay. Every moment you just use this formula lah. R A B need to quickly and then this one you need to use R A C and then this one R A C cross product with the F. Okay, and then similar to the Y, do you have NAY here? No, right? So there is no moment for the Y axis at the point A. So we will only have the moment B at the Y axis plus moment of B at the moment of C at the Y axis plus moment of D at the Y axis equal to 0. So this thing also you need to use R A B F B R A C F C R A D F D. Okay. But if you still remember, last class I talked about moment of an axis, is it? Because we want to find the x axis, is why you need to find u ax. Remember that? So that's why you learn this thing. Okay, the moment at above an axis. This will be u dot sorry, ini u bx, ini u cx, u dx. This one u by, u by, u cy, u dy. And then for the similar lah for the z, mbz plus mcz plus mdz equal to 0. So this one you will have u bz dot rab cross product with the f b after that. Okay. Tertinggal. Oh, another MZ. Yeah. I forget to put this one. Actually, we have MZ. Okay.